so ladies and gentlemen, this is exponential functions, okay? Here's my new equation. Now, what I really want you to remember is the A is going to be the y-intercept, okay? Let's go to the back side. I want to remind you again, when do you have something exponential and when do you have something linear, okay? Can someone raise their hand in person if they remember what is the rule if you have an exponential growth? Andrew.
You have to times something multiple times.
So you have a multiply pattern. Remember how I told you yesterday? So you can't divide. If you see it as a dividing pattern, you can always convert it to a multiply pattern because it's wrong if you write divide. So like right now, I know you see it as divide by 2, divide by 2, divide by 2. But guys, dividing by 2 is the same thing as timesing it by 1/2, right? Okay, now some of you are like, how did these kids get 1/2 so quickly? Well, here's the rule or the general rule of thumb. If you don't know what the timesing rule is, what you can do is you can take the second number, so 4, and divide it by the first number, and it'll tell you what your multiply pattern is. So it looks like 0.5, if I change it into a fraction, is multiplying it by 1/2. Okay? Let me show you another example because this one's kind of obvious. What if I have a table and I have like, I don't know, let's have 26 and then I have 4. Okay, next. And then so I don't know what I'm dividing by. I don't even know what I'm multiplying by. So to see what your pattern is, you take your second number and divide it by your first. Oh, that's a really bad decimal. I'm multiplying it by, but change it back into a fraction. Oh, it looks like my multiply pattern is times 2/13 times 2/13 times 2/13. Okay, so that's how you can always see what your multiply pattern is. Yes, Andrew?
Can you just simplify that fraction?
Yeah, you basically simplify the fraction. Yes. Okay. So then this one, can someone online unmute themselves or type in, what is the rule again if it was linear?
Oh,
Someone online.
okay. Add and subtract.
Thank you guys. It's an adding subtracting pattern. Okay, it can be add or subtract. So like this one, it looks like I'm adding 4, adding 4, adding 4. And remember, all of this stuff is contingent on whether your x's also have a pattern. 1, 2, 3, 4. That's a pattern. 1, 2, 3, 4. That's also a +1 pattern. Okay, so you're okay. All right. Now let's get into the tofu and potatoes of this lesson. As you guys, you make meat haters would not allow me to say yesterday. All right, so here's my equation. Let's go ahead and figure out what these 3 things are. Okay, so I'm going to write this a little bit bigger just so you guys can see. Here's my equation. I want to find the y-intercept. Can someone in person raise their hand and tell us what is the y-intercept? The y-intercept is letter A. Haley, what do you think?
1.
Yeah, I don't see a number, right? So if you don't see a number, it's always 1 times. So my y-intercept, you can write 1, or you can say 0, 1, the point. Either one is fine. Okay, my asymptote. All right, that was the new one, and that's kind of, I'll be talking about that later again. But if I were to type my equation into my graph, and I look at it, remember the meaning of the asymptote is what number does it get really, really close to, but never actually touches? Does anyone online remember or know what number does it get really close to? Online. Thank you. It's 0, right? So the asymptote, it gets really close to the 0, but it never actually touches. And if you don't believe the graph, then go to your table, right? You're going from like 9 to 3 to 1 to 0.3 to 0.1 to 0.01 to 0.001. Like, and you see how, remember how we talked about this yesterday? 1.7 e negative 5 means that you're basically taking 1.7 and taking your decimal and going backwards because it's negative 5 times. 1, 2, 3, 4, 5. So you have like 0.00017, right? And so if you keep on going up, it gets really close to 0, but it never actually touches. You're just moving your decimal back more 17 times, right? You're moving your decimal back how many times? 26 times here. Okay, so it's really close to 0, but it never actually touches. Now remember, the asymptote is not a point, it's a line. So if I look back at this picture, is this an x equals or a y equals, guys? Y equals, good, right? You would think x because it's the x-axis, but then think it's always the opposite. So your asymptote is always the line, y equals 0. And then finally this, it's asking me to plug it back in. If x equals 5, plug in x as 5. What would y equal? I don't know. So just plug it in your calculator. 3 to the x. Oh, x is 5. Did anyone get that answer? Haley? 243. Okay. So that's it. That's all we're doing. Okay. So let's do this one really quick then. Okay. 3 parentheses 4 to the x power. All right. Someone online, shout it out or type it in. What number is the y-intercept? 3. Thank you. 0, 3 or just 3. Thank you guys. All right. My asymptote. You really don't know what the asymptote is unless you look at your picture. Okay. So you have 3 parentheses 4. Make sure you put, if you see parentheses, write parentheses. If you see something, like make it look exactly like your problem. Now look at your picture. Someone in person, can you tell us what is your asymptote here? Lance? 0. Good, but it's a line, so it's what equals 0? Thank you. Now remember how we said it's not always 0? I'm just showing you the most basic today. But once we get more complicated, you're going to have things like, I don't know, this, where look, your asymptote is not at 0 anymore. It's at -6. Okay, so just heads up. And then you can just plug it in later and then figure it out. Okay, all right. Now, Evan, this is for you. Okay, this is, let me tell you a real life like explanation of what the asymptote means. Okay, because some of you are like, okay, well, I get how to find it, but why does it even matter? All right. So let's pretend it's Thanksgiving again. Let's rewind, I don't know, 5 days or however many days Thanksgiving was. And let's pretend you guys are baking a pie, okay? So let's talk about your oven temperatures. So right now we have let's say time, and let's go in minutes. And then you have your temperature of your oven, okay? So at 0 minutes, how many, or what is the degree of your oven at 0 minutes?
0.
No, if it were 0, then it'd be cold.
Exactly.
So
Room temperature.
room temperature. Okay, so let's say that your room temperature is 70. I don't know, whatever. Okay, your room temperature is 70. Now, let's say you want to put the pie in. So let's say 5 minutes, 10 minutes, 15, 20. You don't have to write this down. I'm just showing you. 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. Okay, good enough. So let's say that you turn on your oven. It needs to heat up, right? So it goes from 70, 5 minutes later, maybe it goes to 100. 5 minutes later, maybe it goes to like 200. 15 minutes or 5 minutes later, it goes to like 250, then maybe 375. Okay, so right here at the 25-minute mark, you put the pie in because your pot or your oven has preheated to 375. So now let's cook it. So it's 375, 375, 375 for as long as you need to cook your pie. So let's say here, your pie is done. So you take your pie out. Well, okay, so now your oven cools down, right? Because it goes back to room temperature. So maybe now it's like 300 and then like 250, then 200, then 120, then 80. But okay, so as time goes on, what number is it going to get really close to but never touch? Andrew? The 70, right? So now it's like maybe like 79, 77, 73, 71, 70, 70.9, 70.8, 70.7. Do you see how, like, this is like your classic example of an asymptote, right? It's never going to touch the 70, but it's going to get really close.
Yeah, like,
What?
Wouldn't it actually go to 70?
Well, okay, so wouldn't it actually eventually go to 70? Maybe in many, many days, but if you just shut off your oven and close it, it has a pretty good seal, right? So it's never going to be the outside temperature, maybe unless you like, maybe if you leave it there for like, I don't know, a week or something, but
I don't know about that long, but
yeah, okay, so maybe not your perfect example of an asymptote, but pretty darn close of how I can explain what an asymptote looks like, okay? Yes.
why don't we do that all the way to 375 when it goes down to 80? Why don't we just cook it at 80?
Well, if you cook something at 80, it won't actually cook,
Oh,
right? Like you need higher heat. Like, okay, so Andrew, are all of us cooking right now because we're in room temperature, right? Like, No, okay. We're all cooking. I guess we are all cooking because we're slowly dying. Okay. Let's go to this paper. So go to this paper from yesterday. We're going to finish the last two. Okay, then you can do your level work. Okay, we had the last two to do. So let's do these last two. Okay, so 10 and 11. So for number 10, it looks like we had a couple things that we had to figure out. We had to figure out what was the y-intercept, what was the domain, what was the range, and what was the asymptote. Those were the four things we had to figure out, and we had to graph it. So remember, for graphing it, the easiest thing to do is just put it in your calculator, okay? There is a way that you can do it by hand, but you're gonna learn that when you get to like pre-calculus. It's just way too complicated for you to do it by hand right now, okay? So 1/2, parentheses, 6 to the x power. So type it in exactly as you see it with parentheses and everything. And remember what I said yesterday, if you just look at your picture and come on, and you're just like, oh, okay, that looks like that. Boom, I'm done. No, that's not okay. You would get it marked wrong, okay? With any teacher, any year, you need to at least have some points. So let me go to the table. Oh, darn it, I'm already at -54. It's taking forever to scroll back down. So find 3 points you want to do on your graph. Any 3 points. It doesn't have to be the same as mine. So I have like 0/2, 1, 3, darn it, 218. Okay, that's too high. So maybe I'll do like -1. -1.08. That's basically at 0. Okay, so now that I have 3 dots, now I can draw my curve because it's still a curve. Okay, someone online, y-intercept, go. Yoo-hoo, someone online. Thank you, it's 1/2, or you can say 0, 1/2. If you really want to say 0.5, that's fine. As long as your decimal is not repeated, you can always write it as a decimal. Okay, domain, someone in person. Does anyone remember from yesterday? Hudson?
All real numbers.
All real numbers. Let me explain why it's all real numbers. Remember, domain is x, right? In the center. You always have your alligators eat to the right. Your x means how far to the left you go and how far up you go. So how far to the left? Okay, negative infinity. How far to the right? Positive infinity. So remember, if you have infinities on both sides, you basically cross it out and you write all real numbers. Okay, range. This one's a little bit more tricky. Andrew?
No, I have a question about the
Sure.
In what situation would it not be over?
Yeah, so in what situation would it not be all real numbers? For exponentials, no situation. Yeah. Okay, Lance? Close, but do you see how your picture is going up? So it's not less than 0. Yeah, y is greater than 0. So let me show you how this works again. You have y in the center. Your inequality is always e to the right. Okay, so how far down do I go? It looks like it goes to 0, but it never actually touches. So remember, if it never actually touches, it's not or equal to, it's just less than. And then how far high do you go? Infinity and beyond.
Be greater than?
What?
Be greater than?
Yeah, so then so if you have infinity on one side, you can just cross it out. So your final answer is 0 is less than y, or y is greater than 0. Either one is fine. Just make sure it's not or equal to, right? It's just greater than. All right, asymptote, someone online. What do we think? X-axis. Thank you. So you can write that your asymptote is the x-axis because it technically is the x-axis. Or you can be very specific and you can write what?
Y equals 0.
Y equals 0. Either one is fine. X-axis or y equals 0 is fine. It's true. It is the x-axis. I didn't think of that yet. All right. Last one. This one's going to look like the last one on your level work, okay? That's why I want to kind of do something similar. So graph these two. Then how are the y-intercept and the domain and the range affected? How is it affected? How is it changed? I don't know. So let's go and graph them both. Wait, hold on. Y-intercept. I can just look at the y-intercepts and see how they are affected. Does anyone think they know in person? How are these y-intercepts affected, or how did they change? Andrew?
It got bigger.
It got bigger. It went from what to what?
2 to 3.
Not 2 to 3.
No. 1 to 3.
1 to 3, right? Because the y-intercept is that first number. So it's 1, imaginary 1. So it changed from 1 to 3. That's how your y-intercept was affected. Now for your domain and range, I don't know. So why don't we just graph both of them in the same picture? So do you see how I'm just putting both of them in my calculator under y1 and y2? And then looking at both pictures, oh, you can also see here how your y-intercept went from 1 and it goes to 3. Okay, domain. Does anyone think they know how was the domain affected or not affected? It wasn't. That's right. So I would say it stayed the same because they are both what?
All real numbers.
All real numbers. Okay, so how was your range affected? Same, right? So it still also stayed the same. So it stayed the same. And what was the range here?
Y is greater than 0.
Y is greater than 0. Thank you. Not greater than or equal to, just greater than. Yes. Yep. This is kind of like your starter. Okay, ladies and gentlemen. So at this time, you are going to work on your level work. You have 18 minutes left of class, okay? Your level work, you really don't have any work to show on any of the problems. There's really no work to show, okay? But guys, on your level work, there are